Recording in.
Hello, everybody. Welcome to my virtual class. I hereby welcome you to the topic of today. We shall discuss something in mechanics of senior 3 physics, and we shall have motion, and our today's subtopic will be acceleration due to gravity. And under acceleration due to gravity, we aim at achieving basically few objectives. And these objectives are as follows. We shall have a definition of acceleration due to gravity. We shall have a definition of gravity and gravitational force, explain acceleration due to gravity, and also we state some actual real-life examples of acceleration due to gravity. I pray we stay and we remain focused to achieve this explanation as we begin our display and presentation. Friends, if you think of acceleration, what could acceleration be? Imagine a car moving. Acceleration, imagine a car moving from a certain point A. If we imagine a car moving from certain point A, and we start our timing from point A going to point B. Yes, our study starts from point A going to point B as the clock reads. Yes, as the clock reads, you find that the time taken, the variation in the time taken for the car to move from point A to point B gives us the difference. It gives us the time that the cars consume on the way. So the velocity at point A is our initial velocity, and the velocity at point B is our final velocity. So the difference in the velocity gives us the change in velocity. So the change in velocity per unit time taken, that is why we are timing our motion. So the difference in velocity per unit time taken gives us what we call acceleration. So by definition, acceleration is the rate of change of velocity of an object with respect to time. Mathematically, we present acceleration as a ratio of change in velocity to time. So ratio of change in velocity to time gives us acceleration. I think that is quite better to appreciate. And if so, then what do you understand by gravitation? To understand gravitation, friends, in physics generally, gravitation is a pull on an object. Yes, gravitation is a pull on an object. So imagine this bunch of mango, this bunch of ripened mango. Yes, it's like that they're not ripened, and when they ripen, what do you think happens? Their attachment weakens, and as the attachment weakens, they are released in free air. Imagine them falling freely. Yes, imagine the mango falling freely. Imagine that. What do you think has been pulling those mango down? It is the pull of gravitation. As in physics, we describe gravitation as the force that pulls two objects together. Pulling two objects together means that there exist masses. These ripened mangoes are weight, okay, they have weight. So having weight, they will be attracted to the weight of the mass, weight of the earth. And having been attracted to the weight of the earth, you find that they are going to be pulled down to the earth. Pulling them down to the earth gives us the pull of gravity on such an object as the ripened mango falls freely from the top of the trees. So you will appreciate that the motion of these fruits falling from the trees is due to the magnitude of the earth mass, and then the magnitude of the minor magnitude of the fruits themselves. So with that in mind, we also put a recommendation that the force of attraction between masses in the universe, the force of attraction between masses in the universe exists between all the masses, like mass 1 and mass 2, as suggested by Sir Isaac Newton in the early 17th century. And he formulated a gravitational force, a gravitational law that states the gravitational force that exists between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance apart. That is to say, when we see our our diagram here, the mass 1 and mass 2, you find that there exists a distance between them. So this is our mango and this is the earth. So this is a space, a vicinity. So R is the distance between the mango and then the earth surface. So falling of the mango to the earth surface is due to the attraction of the gravitational force of attraction. Understand? So that is due to the product of their masses. And since the mass of that mango is minor, it is going to be attracted to the Earth's surface due to the vast mass of the Earth. And with that, we have that Isaac Newton's law of gravitation applies in this case. Friends, you will also appreciate that what gravity is giving us the real definition of what the acceleration due to gravity is. Our next key point here is gravity, because we have seen that acceleration and then there is gravitation, and now we are talking about gravity. What do you understand by the term gravity? Yes, to appreciate gravity, we just know that gravity is specifically the pull of an object towards the Earth. Our planet today, we are studying the Earth. Yes, so the pull, the force that pulls is gravitational force. Now, since the force that pulls is gravitational force, then the gravity pulls the gravity is now the pull of that object towards the Earth's surface as the mango fell freely. Now, what is acceleration due to gravity in general? Never be worried. Acceleration due to gravity is simply the acceleration gained by the object due to the gravitational pull or the gravitational force. The acceleration gained. So when the acceleration is gained, yes, let us not give much word. Let's go to visualization of this. Let us see this mango again. As the mango was at rest before it ripens and weakens and to be freely released, they will be falling. Okay, they will have weakened in the attachment, yes, after ripening. Then they are released in the space. Now they gain some acceleration. Gaining acceleration downwards, they will fall freely. Falling freely, that means their velocity will change. So the gain in acceleration was due to the gravitational force. And that's why we are explaining this in the sense that the gravitational force is causing acceleration. And this acceleration caused by gravitational force is called acceleration due to gravity in real sense. And that is also the reason as to why we are accessing mangoes in any case possible. Anyone, even a young child, can wait for the mango and then picks from down. It will have been brought down due to acceleration with the gravity, the force that pulls the mango up from the trees down to the earth's surface. So for that matter, children are always advised not to climb trees because they are also going to fall freely, and falling freely, just know they are also going to experience the acceleration due to gravity because all of us, we have masses. So therefore, acceleration due to gravity applies to all masses on the earth, all masses in the universe, so they are attracted. So some practical applications of the acceleration due to gravity, as we shall also see in the next line, but here we now know that the acceleration is a change of velocity with respect to time. So acceleration being a change of velocity with respect to time gives us a SI unit, the standard international unit of meters per second square, because we are dividing the SI unit for velocity by another time. So dividing SI unit of velocity by another time means it is another second, because the SI unit for time is seconds. So per second squared. And on the planet Earth, we have discovered that by experiment, we have discovered that the acceleration due to gravity in the planet, in the atmospheric region of the Earth, is 9.81 meters per second. By practical, and I beg you click on our subscription button so that you get the practical videos that I will be uploading in the couple of minutes or days to come, because I'm preparing them and I'm ready to upload them. As I will request you hit on the subscription button. So as we continue also to present our discussion of today, acceleration due to gravity is known. Now, what are the practical examples of acceleration due to gravity? Imagine falling bodies. We have just been seeing mangoes falling. We have also just been seeing a lot of attractions within masses. So imagine you have released a paper in the space. Where do you think it goes? I don't want to talk of heavy masses. Let's come down to these small masses, because they all have weight due to existence of mass in them. So a tissue paper falls freely. A tissue paper falls freely, and it falls more slowly than a bottle, a steel bottle. Just try to do that in your practical time, and you will see that we are practically seeing it in real life. So our next real life presentation of acceleration due to gravity is the satellite orbiting the planets and other celestial bodies like the moon and the earth. And then they all move. They are also stuck in their positions to move around the planet due to the attraction of gravity. Yes, so the gravitational pull of attraction holds responsible for keeping bodies into contact. Is it trying to explain that bodies keeps in contact because of acceleration due to gravity, because of the force of pull that they pull each other together and they hold into constant existence. I think you appreciate that. Our next example is the fruit we have just been demonstrating. It is the free-falling fruits from the mango trees, from whichever trees you may experience in your vicinity over there. I would love to appreciate the time you've given me. And I would love to remind us also that it is not the acceleration due to gravity that is responsible. It is not the acceleration due to gravity that is responsible for people falling in love. It was recommended by Albert Einstein in his German version of the statement. Here I quote. So if you're able to read the German version, here you are. You can bear me witness that the interpretation is here in red. So it is like gravity cannot be held responsible for people falling in love, as he recommended in his letter in 1981. I appreciate the time you've given me, and I would request that you hit the subscription button such that you don't miss our physical science videos that will be coming up next. I appreciate that, and I wish you all the best while we serve the nation and the world for a change in the physical science. Thanks for that, and we meet next time. Never shall you miss all my videos by clicking the subscription button. Thanks.